Good morning and good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. If you've been following along, you know October has been jam-packed with live lessons, live virtual field trips, particularly looking at space exploration. So we've had astronauts and engineers and scientists who are helping us explore beyond the Earth into our solar system and out into the universe. But most important of all, allowing us to turn a lens to look back at our planet in ways we never could before, to see how it's changing and the impact that we are having on it. So exploringbytheseat.com is where you want to head to see all the space exploration content we have coming up over the rest of this October. And there's other cool lessons there that you can find. So we hope to see your classrooms joining us throughout the rest of this month. Okay, let's get into some of that space exploration action. Today, we are going to do something a little bit different. We've talked a lot about the various rovers like Curiosity and Perseverance. Today, we're going to talk about the Mars Ingenuity Helicopter. And to help us out is Martin Cacan. He is a guidance, navigation, and control engineer at NASA's Jet Propulsion Laboratory. He was the chief pilot of the Ingenuity Helicopter, assisting in over 50 flights through the Martian atmosphere. And he continues to work on designing the next Martian rotorcraft, which is pretty darn cool. So I'm going to reach backstage. We'll see if we can get Martin in here with us right now. There we go. Hey, Martin, how are you?
I'm wonderful, wonderful. I'm very excited to be here.
Excellent. Well, it is great to have you live with us today. We have a great group of classrooms hanging out with us in Canada and the US. We actually have several who are on the West Coast, so might be impacted by some earthquake drills at some point. But let's get right into it because this is so cool. This is such an amazing achievement. The first helicopter flights on Mars. It's pretty awesome.
Yeah, it was super monumental and very excited to be part of and excited to bring this here to all the classrooms. So this is great.
All right, Martin, let's get you front and center. You've got a presentation here for us as well.
Yeah. So let's dig into it. There's a lot to try and show. It's hard to, limit the content here. So just want to give you guys a brief background. Again, you guys probably heard about the Perseverance rover previously. And this little Ingenuity helicopter came with it. It basically came in on the belly of the rover and was deployed. And then the rover drove off and kind of took this selfie of us here. And then, the helicopter basically flew and operated independently from the rover, except for communications. And I'll talk a little bit about that. But, what makes up a helicopter? I have a little model here in front of me as well. But, importantly, we have the rotors that spin and, give us lift. We have the solar panel, right, that just like what we have here on Earth, soaks up the sun's rays and gives us power. And here down below in the fuselage is where all the important stuff is kept. We have our batteries, we have our sensors. But the really cool thing about this is that a lot of the parts that you would find in here come from like old cell phones, right? So like our the batteries in here come from just like a cordless drill. The camera on here comes from like an old Galaxy phone. Some of the other sensors come from like old Pixel phones. So, we really just took off-the-shelf parts and made something new here, which was really unique. So, the question is though, like how does one, get a helicopter on Mars? How do we even come up with this idea? And, it all really, starts with an inspiration, and it comes with an initial test. Like, is this even possible? And so, we got our best engineers together and we went into a vacuum chamber. So we were able to replicate the thin Martian atmosphere. And we were able to prove, maybe not entirely successfully, but as a proof of concept that we were able to fly in a Martian-like environment. And this really kicked off, the entire mission. But as you can see, right, we broke, there at the end and, all learning, comes with failure, right? But we learn from that. We're able to move on from that, gather a lot of data. And that was really the proof that showed that this all worked. And, years more kind of development and testing. And we had our first flight on Mars.
Altimeter data confirms that Ingenuity has performed its first flight of a powered aircraft to another planet.
So there we go. First, powered flight on another planet. The rover stayed next to us to capture this video.
We can now say that human beings have flown a rotorcraft on another planet. Let's get back to work.
So yeah, such a fun team to be part of, and was such an inaugural moment. And something that started as just like a dream that, evolved into, this tiny tree that, we thought was just going to be around for a couple flights, ended up traversing this entire region of Mars over 10 miles through, all this different terrain, and, was an extreme accomplishment. So I want to just spend a couple minutes and talk about how we pilot a helicopter on Mars. I always get asked this question. Lo and behold, it's not like we do it on Earth. Perhaps no surprise. It takes, 6 or more minutes for a signal to go to Mars and come back. And so you have to put a lot of the smarts onto the vehicle. And so the helicopter is a little bit more like, like a Tesla, right? That it kind of has the ability to drive itself a little bit. So what does it actually mean to pilot a helicopter? So like any pilot, you have to make sure you find, safe places to land, basically find your, next airport, next landing strip. And so we use basically satellite images of Mars. Think about like Google Earth, but Mars. And so we look through all those pictures and we try and find these safe areas. So on the left in yellow here, right, these were identified as safe landing spaces. And then basically as the pilot, we have to try and design and test to get a flight plan that gets us from A to B. So, in this case, we started here. We were going to come across this. You can't quite tell, but this is a very steep downhill as we come across. And then we're going to then kind of come up the airstrip and try and land. We do a lot of simulation testing using our computers and kind of test to make sure that everything's going to look well. So over 40 or 80 simulations, you see the vehicle trajectory spread out a little bit, but stayed all nicely within the final airfield. So as a pilot, we give it our approval. And so then what really happens? We take that plan, we uplink it to Mars. We have to wait usually at least 24 hours as the data goes to Mars, goes from a satellite down to the rover. From the rover, the data is sent to the helicopter. At this point, the helicopter does its flight. And then afterwards, it sends its data back to the rover, back to a satellite around Mars, and then sends the data back down to Earth. So that, again, takes some time. But when it's all done, you have this amazing accomplishment of seeing, the data and the pictures that you took, right? So this picture on the left is where this camera is. Basically, it's the image we were taking when we were coming to this dog leg. And it really allowed us for the first time to see close up what this terrain was like. The helicopter often operated in advance ahead of the rover. And so the helicopter was often the first vehicle platform to kind of see this new terrain and give that information to the rover so that they could use that and plan better. And one of the things you see here on the right is as the vehicle is coming down to land, you see that, we came down to land on this beautiful sandy little slope. And it's right where we were targeting, right? You can kind of see there's this sand ripple right where we were targeted, and we landed on it perfectly. So it was just an excellent flight. But, there's just many hours go into making that perfect plan. You can see here the plan in the bottom left corner has all these zigzags and all these places we were trying to capture an excellent photo. And lo and behold, we really captured, we captured this here, which was one of my favorites across the entire mission. You have what's called Belva Crater in the background. You see the rover tracks going from right to left through here. You see the rover in the background and our shadow here in the foreground. So this was actually the only selfie that we were able to take with ourselves and the rover. So this was just such an amazing moment as the pilot. You get this image downlink from Mars, and it really feels like you just reached out 2 million miles and click, took this photo. So when you do all that planning and you see this, it's so rewarding. It's so fun. And so, yeah, I just want to kind of show you a lot of the pictures and journeys that we took along the way really quickly. We were able to explore basically the landing equipment that got us to Mars. Basically, there's a whole system that's sacrificed just to get the rover and the helicopter to the surface. And we were able to go look at it and explore it and take these images, which were really cool. When possible, we would try and take flights near the rover, and the rover would take, images or video of us flying. There's always something new to learn working on Mars. And so one of the studies they're really curious about is, how does dust kicked up by all the rotor blades? We have a good understanding of how this works on Earth, but, how does it work on Mars with, the different atmosphere, with the different gravity? And so one of the cool things that was done here you can see is that they, added some filtering to highlight where images, parts of the images change. So you can really see, the dust flare up activity here. So again, just always a lesson to learn. The mission got harder as we went. We constantly traveled through more difficult terrain. Ingenuity on the left is pretty easy to spot. Ingenuity on the right might take you a minute, but I'll give you a clue. It's in the green circle. And, it's just really impressive because during this whole time, we constantly were trying to push the envelope. We wanted to go further. So to go further, you have to go faster. And to go faster, we needed to fly higher. And so, we just constantly were setting new records on Mars. Most of what we did was helping the scientists, right, by trying to observe rock formations. They have a really expensive vehicle that's, in the name of science, trying to understand the formation and life, the origins of life on Mars. So they would go, let's say, to one rock formation, but they're like, well, there's this other rock formation over there. Are they the same rock formations? They would just, they would have questions. And we'd often use our mobility to fly over and look at some of the rock. So these two on the left are aerial images that we took. And the one on the right, we actually landed on the rock to try and get a view. And we found, this very volcanic rock. And so that was really exciting find. But, most of the fun was just looking out the window during our, journey across Mars. Just beautiful scenes, with these dune landscapes, beautiful desert scenery. If it wasn't just absolutely cold and, no oxygen, it could be a nice place to visit. Here we are in the Delta. Beautiful little hill we passed by. But, all good things come to an end. And as we were traveling up this ancient river valley that has now kind of turned into a dune field, we had a hard landing and broke several of our rotors. So you can see, this is the first image we got down from Mars, that the shadow cast shows that our, blade is damaged. I really wish this was live so you guys could see this in real life, but this is one of the flight spares that we have of this Ingenuity rotor. The crazy thing about this is how light this is. I mean, if I could, you could hold this easily on a finger if I could balance it. I mean, this weighs maybe like a couple pieces of paper. I mean, just absolutely marvel of engineering here. But you can see this is what the blade is supposed to look like. And you can imagine if a shadow is cast from here, you're going to see this full tip come out. And from the image that we show, It's very clear that the blade looks like it's broken, around here. So we had a hard landing and damaged our rotors, but that's okay, right? Everything is a learning experience, right? And having a hard landing and damaging the vehicle was something we were able to learn from. We conducted basically the first accident investigation on another world, kind of put on our FAA shirts, and tried to understand to the best of our ability what went wrong and how can we best influence the next projects to come. So Ingenuity ended its 3-year mission, but it really exceeded expectations. It flew 72 times on Mars with the original goal of just 5 flights. And really has started a revolution in aerial platforms on Mars. There's just so much discussion, so much happening. It's really exciting time for kind of this aerial mobility. And as you guys are all here and you're getting inspired, it's great to see all the kids get inspired. Honestly, the adults get just inspired talking about this, so it's really exciting. But the one thing I'll say, though, is that, Ingenuity on the surface of Mars is still working. It still has a solar panel. It gets charged. It turns on every day. The problem is we just can't fly any longer. And so the rover has continued its mission and driven away from us. And so we rely on the rover, as I talked about earlier, to do communications. So we just no longer can communicate to the helicopter, but it continues to sit there. It continues to take data every day, take pictures. So it's kind of just this lasting weather station. And hopefully if the rover comes back or, humans go to Mars, we'd be able to collect this and capture the years of data it's going to continue to take, which is, really exciting. So with that, I'll just, I'll end it here. I know there's a lot of room for questions. Just end it with this great photo here of Ingenuity. There's also, I'll just leave this up. So if anyone wants to try and write this down or grab a photo, this is our official, kind of NASA website that has a lot of fun information on the Mars Ingenuity helicopter, has a lot of pictures, posters. There's a cool little gyrocopter you can make that you can, kind of come out and spin and make the Ingenuity helicopter. So a lot of cool things there. So with that, I'll turn it back to Joe and open it up for questions.
All right. Very cool, Martin. I'm going to take that screen share down. That was awesome. It's such a cool project. And what I love about all the projects that we connect with, all the engineers, they talk about how long something was supposed to last and then how much longer it keeps going, which I think is a real testament to the work of all the engineers at JPL. You look at the Voyagers, Voyager 1 and 2, who 40 years on, they're still sending back data. They can still be sent instructions. Pretty great team you get to work with, some amazing engineers.
Yeah, no, it's a dream job. So I'm fortunate.
Yeah, very cool. All right. Well, I am going to hold off on just a minute. I made a Kahoot quiz while you're presenting, but I know a few classes might have had to take part in the drill. So I'm going to save the Kahoot quiz and maybe do it in 5-10 minutes or so. So in the meantime, though, I'm going to start taking some questions. So I'm going to start reaching into our classrooms and getting their questions. And then I'll take some from YouTube. So if you're tuning in on YouTube, don't be shy. Use the chat sidebar. So let's start grabbing some classrooms. So I'm going to start with, in California, we have some 5th graders with Miss Carson. I'm going to see if I can get them in here front and center. There they are. Hey, 5th graders.
Hi, we were wondering if you could tell us how long it takes for a person or a robot to get to Mars, with it being 2 million miles away.
Yeah, it takes about 6 to 9 months, depending on when you go. So it's quite a road trip.
And then another question we had was, are we able to come back from Mars? So are the things that we drop off there, can we get them back, or are they there forever?
That is honestly one of JPL's biggest goals right now, is to try and bring rock samples home. So Perseverance' current mission is collecting all these rock samples, and Ingenuity at the start was helping, Perseverance find what rocks it wanted to try and collect. And the next mission we're trying to do is to bring those things home, which will be the first time we'll ever have gotten Martian material back to Earth.
That's amazing. Do you have time for 2 more?
Yeah, let's get a couple more and then we'll go to the next class.
All right, Aaliyah, go ahead, please.
Do you think we'll be able to have life on Mars?
That's something we're studying right now, is to see if there's possibility for life.
I don't think there's currently life on Mars, or maybe if there is, it's moved way underground and it's going to take us time to find it. But, it seems like there is a lot of evidence that life used to exist. I obviously also believe that, our, human engineering prowess could, put a future civilization on Mars. But I think, for natural life to occur on Mars is, not very likely at the moment.
And then our last one for you is from Peter.
So on the North Poles, is there exactly ice filled with water, or is it like ice that turns to gas?
On Mars, do we know if it's water in the caps?
That's such a great question. We believe it's ice, but we do also, have some goals to try and go and study it better. Does it melt or does it gasify? I'm not actually totally certain. That's a good question.
Thank you so much for your time. We really appreciate being able to talk with you.
Bye.
Yeah, thank
Our turn
I
is
see you have your computers for the Kahoot. We'll play Kahoot in a little bit. Okay, let's grab another classroom here. We have Mrs. Lamb's crew. Some more 5th graders hanging out with us. How we doing, everyone? I see you've got your computers ready too. That's good.
How long did it take to make the helicopter?
Gosh, probably from original kind of inception and testing through its development and, kind of final round of testing. We're talking probably 6 to 8 years. And that's kind of fast for a NASA mission. It takes a long time to, conceptualize, design, and launch.
Yeah, great question.
Thank you.
Why did you guys make it as thin as paper?
Can you repeat that, please?
Why did you guys make it as thin as paper?
the rotor.
The rotor.
Oh, yeah, we made the rotor, very thin and very lightweight, just to try and get lift in the Martian environment, right? So Mars is about 1% of Earth's atmosphere. So it's like trying to fly a helicopter at 100,000 feet on Earth. And I'll just give you a hint. No one does that. It's basically impossible. So, we really had to design something really special. And this was basically what we found worked.
What's your biggest rover? What is your biggest rover you ever built?
The Perseverance rover is basically the biggest rover we've built. It's kind of like the size of a small car. Maybe think of like a Mini Cooper or, like a VW Bug. It's big, it's heavy. And again, Ingenuity, it's hard to see, but this is a full-scale model of it. So it's about 4 feet across in diameter. So you guys are pretty small. So that's probably about your wingspan. Even this little helicopter is actually pretty big. And the whole thing only weighed 5 pounds, which is, I think, a lot of the impressive engineering that went into it.
Thank you so much for taking our question.
Of course. We'll see you for the Kahoot soon. Okay, let's grab Mrs. Carey's crew. How are we doing, 5th graders?
Jill, come on up. I have a question. Why do you guys believe that there's water on Mars, or there used to be water?
Great question. So, a lot of times the geologists study Earth, right, to then understand what's happening on Mars. And so if we go to places on Earth that used to have water, or, if you go to the desert where it gets spring rains and it, gets flooding occasionally, but is otherwise dry, you see certain signs, certain deposits that are left over. And when we go to Mars, we see all the exact same behaviors that we see on Earth of what happens to rock deposition in the presence of water. So there's such a direct one-to-one correlation between what we see on Earth and what we see on Mars that it just gives us very high confidence.
Okay.
Thank you.
Thank you.
Next question.
When the rover fell down in the dune field, did you guys have to bring it back to Earth and repair it, or did you leave it be there?
Yeah, it is still there. I think we're talking about Spirit, or was it Opportunity that got stuck in the dune field? Yeah, things that go to Mars stay on Mars. The population of Mars is robots, as we currently understand it, right? So the things that we have sent there is it.
If you did bring it back, would you have to get like a mini rocket?
Yep.
Yeah, it'd be very expensive, and yeah, we're just not there yet.
Okay, and
But that's part of the reasons why we want to go to the poles, because there's the ice there, and there's potential that you can make rocket fuel from the water ice. So, definitely potential.
Very good. We have one more. Go ahead, Abby.
Of course.
Are you completely certain that there was water on Mars a long time ago?
I don't think we can be entirely certain about anything. Space almost always throws us for a ringer. We come up with our best scientists, come up with our best ideas, and we're often wrong because just the universe is unimaginably complex. But repeated signs of evidence show that there used to be water there. And so, we used to be suspicious, now we have a lot of confidence. So, we're about as close to certain as you can be.
All right.
Thank
Great
you.
questions. We're going to come back your way after the Kahoot. I was holding out because I know there's a class who's with us. I think it's a 6th grade class in BC. They disappeared to do their shake drill, but I don't see them back in their classroom yet. But I think we should get the Kahoot in, and then we'll continue with some more Q&A action. So I'm going to share my screen, and you're going to see our Kahoot page for today. So here we go. And that should come up for you now. Okay. So today you need to go to kahoot.it, kahoot.it, and then it's going to ask you for a PIN number. It is 5536105. Lots of classrooms and computers. You guys can join that way. If not, and it's just up at the front of your room, that's fine too. You can shout out your answers to your teacher. If you're joining from home, scan that QR code. It'll bring you right in here to play along with us. While we wait for some of our auto-generated animal names coming in here, I have a question in the chat from Caesar. Caesar's joining us in Nicaragua, and he'd like to know what the biggest challenge was for the Ingenuity team during the mission.
Oh, that is a great question. Biggest challenge. To a certain extent at times, we always tried to stay ahead of the rover. Just from a communication standpoint, there were multiple reasons why it kind of was advantageous for us to, go ahead and then the rover would catch up, and then go ahead and have the rover would catch up. But that means that you have to be, going where the rover is going to go. And most of the time they're like, we're going to go straight. And you're like, okay, great, we're going to go straight. And then you talk to them the next day and they're like, yeah, we're turning right. Because, they're learning every day as well, where they want to go, where the new science is. And so, to a certain extent, we tried to stay ahead of this vehicle that constantly was changing its mind of where it was trying to go. And so that did lead at one point to, over a month of blackout, where we weren't able to communicate to the rover because, we went straight, the rover turned right, and, it did its little journey and eventually came back to where we were, and the mission continued. But, plans always change, and kind of just having two assets you have to coordinate could be difficult at times.
All right. We still have a few groups trickling in, so I'm going to give it another 30 seconds. While that's happening, Martin, what about the weather on Mars? Was the wind a factor at all?
That is such a great question. They do have, weather events on Mars. We do have a climatologist. So every time, we give our thumbs up to fly, we, like turning into the news in the morning, listening to the morning weather, we have a guy who says, it's going to be this hot, it's going to be these type of flight conditions. But most importantly, what happens is you can have global dust storms on Mars. So when the winds pick up high enough, dust is kicked up into the atmosphere. And basically almost the entire atmosphere across the entire planet can get dusty. And that grounded us for over a month because we are solar powered. And with all the dust in the air, we couldn't charge our battery. And we kind of had to just hunker down for a period of time and, truly weather the storm. So, winds can be very impactful, especially when they, you get these global storm events.
All right. Well, let's play some Kahoot. We're going to hit start. There is some true and false. There's some multiple choice. The quicker you get the right answer in, the more points you are going to get. And then I think I see our BC crew coming back in from outside. So hopefully we can get a couple questions for you, Martin, after we get the Kahoot going together. All right. Here we go. 3-second count in. 3. There we go. 3, 2, and 1. And our first questions are true or false. Ingenuity, did it come in on the back of the rover? So Perseverance, when Ingenuity was on the planet, was it stored? Did it come from the back of the rover? You have 10 more seconds. True or false? Is that true? Is that false? Where was Ingenuity on the rover when it came to be on Mars? All right. Good job to the crew who chose false. It was on the underside, the underbelly. So it could be placed gently on the ground, I'm sure. So good job to our crew who went with false. The Prairie Coyote is in first place. So Martin, when the rover was brought on, was it able to lower itself down? Or sorry, the helicopter, was it lowered down? Did the arm of the rover have to take it off? How did it get onto the ground? Oh, Martin, I think you're on mute. We can't hear you right now.
Sorry, thank you. I'll just use my little model here to demonstrate, but we were right on the belly pan of the rover. So these legs collapse. So if these legs kind of fold in, you can see that the belly of the rover is where my hand is. And basically what happened is this whole thing pivoted down and then was hanging from the bottom of the rover. The legs then deployed out to where you see them now. And then it was dropped, just, an inch or two down to the ground. And that's how we were placed on the surface of Mars.
All right. Very cool. Let's get the Kahoot back up here. There we go. Okay. Next question coming your way. How many flights did Ingenuity take on Mars? Was it 5? Was it 43, 72, or 101 flights? So I see our answers flying in. There's a couple extra seconds here as well because it is a bit more thinking this question. Was it 5, 43, 72, or 101 flights that Ingenuity took on Mars? All right, good job, crew. Overwhelmingly, we went with 72. We know 5 was the plan, so 72 is pretty awesome. And Martin, you were hands-on on at least 50 of those.
Yeah, I joined the team on think flight 14 is the first one I shadowed, and then flight 15 is the first one I had an impact on. And then I think it was around flight 33 that I took over the reins and kind of graduated from a pilot to chief pilot.
All right, pretty cool. The friendly Liger has taken top spot. We've got another true or false coming your way. Mapping safe places to land is one of the first steps to a successful flight. So what do you think? Before the helicopter even takes off, mapping those safe spots is really key to a successful flight. Is that true or is that false? You've got 4 more seconds to lock something in. All right, good job, crew. Absolutely. Especially since you can't see the flight in real time, you have to know where you're going to put that helicopter down. Okay. Artsy Badger, we got lots of movement here. This is our final question. What was Ingenuity's mission? So what was it up to? Was it observing rock formations, photographing the landing site? Was it pushing further and higher, or was it doing all of the above? So observing rock formations, photographing the landing site, pushing further and higher, or all of the above. You have 9 seconds to lock something in. All right, good job, crew. I know it's tempting to click one of the first ones really fast, but sometimes you got to take an extra second to see if it's going to be one of those sneaky all the above questions. Let's take a look at our podium. In third place, we've got the friendly Liger. In our second spot, we've got the nimble Dugong. And holding down that top spot, the outstanding Coral sneaking in at the end to take the Kahoot. All right, let's come back from that screen share, turn off that music, and we have time for a few more questions. And I believe we have our Division 2 crew back, maybe. If you're there, Division 2, just send me a message in the chat. And if you have a question, I'll make sure that we work it in. But I think we can probably do a speed round and visit each of our classrooms really quickly again. So let's mix things up. This time I'm going to go in reverse. Mrs. Carey's crew, do you have a final question for Martin? There they are.
Go ahead. Here it is. How many volcanoes did you see on Mars?
How many volcanoes did we see? With the Ingenuity helicopter, I don't think we saw any. We were in a massive crater, but there is a gigantic volcano on Mars, Olympus Mons. It's the largest single mountain in the entire solar system, but we did not go past it.
All right. That's so cool. That Olympus Mons, 3 times the height of Everest. That's a pretty big volcano. Very, very cool. Okay, Division 2, BC crew says they have a question. I'm going to bring them in. Let's see if we can retrieve a question or two from our group. There we go. Hey, everyone. All right, nice and loud for us.
Hi. My name is
We hear. All right, good to have you with us.
How long does it take for humans to get to Mars?
Okay, so he's wondering, Martin, how long do you think it'll be before we're ready to send that first manned flight to Mars?
That's such a good question. I think everyone has a different opinion. I think it'll happen in our lifetime, but I think it's going to take a while. We're nearly at the point where we have the rocket technology, but there's a lot of other things that have to be better understood. We just don't understand necessarily how well the human body behaves in low or no gravity for extended periods. The longest we've ever had, astronaut on the ISS is just over a year, and so there's just, there's a lot to understand. But, I think, we have obviously the smarts to do it. So I think it'll happen in our lifetime.
Yeah, we've got some business to take care of on the moon first. I think that'll be some great testing for us. can we find water on the poles on the moon? Can we have humans living there? And that's probably going to be the jumping off point maybe for a future mission to Mars. So lots of work to do before we get there. I think our BC crew says they have one more question, so we'll bring them back in and let them get another one.
How long have you been working for the NASA?
I've been working for NASA for almost 10 years. So I was very fortunate. I got hired right out of grad school. So this has been kind of my my first job. And it's been just, a dream come true.
All right. Came in at the right time to get in on the Ingenuity action. Pretty cool. Okay, Miss Lamb's crew. I heard a rumor you might have another one for us.
So I had a question. Why do you name like rovers and drones rather than naming them like normal names? Why would you name them like Perseverance and Ingenuity and like things like that?
That's a great question. Folks like you actually were the ones that named it. NASA usually has a naming competition where, kids and adults can basically write in what they think the name should be and why. So, I can't recall exactly who came up with both Perseverance and Ingenuity, but I'm pretty sure, 2 kids did that. For example, Ingenuity, when it was under development, we called it Leonardo, right? Leonardo's flying machine was the first kind of conceptualized helicopter that, any human had ever thought of and written down, was Leonardo's flying machine. And so, this was the first flying machine that we were conceptualizing on Mars. So we kind of took that name Leonardo. So that was the name of the project on the inside. And then, when we went to go launch and we had this naming competition, we, changed name and put on the Ingenuity hat.
All right. We have one more classroom to visit. Mrs. Carson's crew. You have another question for us.
All right. Hi, we have Jesse with the last question.
Perfect.
Did you use Ingenuity to take a picture of the largest volcano on Mars?
Yeah, sadly we did not. We weren't in that same area. So the one of the earlier rovers, Curiosity or Opportunity, I can't remember which, were on the slopes of, Olympus Mons and got a lot of great photos from it. But the current rover is trying to find, a lot of signs of life in all these old water features. So we're crawling around all these ancient lake beds, ancient river beds. So that's the geography that we're looking for on the current mission. And, we're not over by the volcano.
All right. Well, if you haven't seen it already, classrooms, there's a really cool story. It's been out for a bit that there's a sample that has been collected that hoping one day we can get back to Earth. That is, if it was on Earth, we would say, yes, this is a biosignature, but we have to be careful. We want to try and get it back here so we can test for sure. So the evidence we're waiting for could be sitting on Perseverance right now. We need that Mars sample return in the future to bring it back to us. So we'll keep our fingers crossed that mission will come on the horizon at some stage. Martin, I want to start with a huge shout out to our classrooms. We had such a great crew today joining on YouTube. We had a great crew of camera classrooms. I'm going to bring them in here so we can get one more wave from them. Thank you so much to our crews for hanging out with us. A lot of West Coast classrooms today, which is pretty cool. It was great to see you. It was great to get your questions and play Kahoot. A shout out to our classrooms on YouTube as well. Always great to have you hanging out with us. And Martin, thank you so much for letting us steal some of your time, showing us those really cool props and taking us behind the scenes on the Ingenuity mission.
Yeah, super happy to be here and share the mission and all of our accomplishments. It's been amazing.
All right. Well, we hope to see your classrooms joining us. We have lots more space action coming up in the month of October. So exploringbytheseat.com is where you want to head. But we'll say goodbye for now and hope everyone has a great rest of the week. Thanks, everyone.
Bye.
All right.